So, today I'm going to teach you how to graph the most common trigonometric functions, sine and cosine, without using a calculator. You actually only need to know the transformation factors, which are the amplitude, the period, the phase shift, and the vertical shift, for a trig function to be able to graph it. And we can determine all these factors from a function's expression. And this video will also include some examples where you can test your new knowledge. So let's get started. So this program is showing a graph of this sine function over here, which is written in a general form. And the sliders here at the top let me change the variables in the function. And of course we also have a reset button that let me reset all the sliders. But now we're going to try to make some connections between the transformation factors and the variables in this function. Let's start by trying to change the a value a bit. So, by increasing the value of a, we can see that the amplitude of a function, which is the distance from one peak to the center line, seems to increase. And that's also the case, because the amplitude for a trigonometric function is equal to the absolute value of this variable a. The next variable is k, and we can see here that the period, which is the distance between two identical points, shortens with bigger values on k. And the connection between the period and the k value is that the period is equal to 2 pi divided by the absolute value of k. Okay, let's skip c for the time being and move on to d. The variable d is in charge of the vertical shift of a function. So if you increase d, you will see that the function is raised a bit. And if we decrease it, we can see that it lowers the whole function. So now we only have a phase shift left and only one variable left. And the connection between them is that if we increase the variable c, we'll see that the function is moved to the left. And if we decrease it, we can see that the function moves to the right. So a phase shift for a trigonometric function is equal to minus c. So with that said, let's move on to some examples. I will add a secret function, this red function here. I would like you to pause the video and try to determine the transformation factors for this function. Let's start by determining the amplitude. And the amplitude is the distance between one of the peaks, the highest or the lowest, and the center line, which in this case is minus 2. And we can see here that the highest peak is 0, and the distance between 0 and minus 2 is 2. And therefore the amplitude is going to be 2. Let me plug that in right away. Yeah, that seems to match pretty well. Let's continue with another transformation factor. We can observe in the graph that the peaks are on the same distance from each other for both functions. And that means that the two functions have the same period. And we can also see that the peaks line up. So there's no phase difference between the two functions either. But the red function seems to have been moved 2 steps down. So therefore the d value is going to be minus 2. So that was one example. Determine a function's transformation factors by just looking at the graph. But I actually got 2 more secret functions. But at the same time I don't want to bore you, so I will just link this program that is free to use in the description, so you can play around with it yourself. And please let me know in the comments if you tried it and managed to solve the other secret functions. Let's continue by doing some more examples. Our task is to try to determine the amplitude, the period, the phase shift, and the vertical shift for this function here in the table. And to do that, we have to use the rules that we just have discovered. And one important thing to remember is that we have shown that all these rules apply to the sine function, but they do in fact also apply to the cosine function. So that is a good thing to remember. So let's try to do the problems. Our first function is 2 sine 3 times x plus 1. And if we use our rules, we can see that the amplitude is going to be 2, since that is the number in front of the trigonometric function, and the period is going to be 2 pi divided by the absolute value of k, and k in this case is 3, so the period is therefore going to be 2 pi divided by 3. The phase shift is the same as the negative of the c value. And since our c value was 1, our phase shift is going to be -1. And we can also see that our d value is going to be 0, since our function don't have a second term to it. And our vertical shift is therefore also going to be equal to 0. The next function is a bit trickier, because we know how to handle trigonometric functions that are written in this form here. But this function here is not exactly the same, as you can see. We are missing the k value, but we can fix that. Let's try to rewrite our function so that it matches our formula. Let's see, sine 2x minus 2 can be rewritten as sine 2 and brackets x minus 1. And now we have it written in the way we want. And now we can quite easy, again, with the help of rules, determine the different transformation factors. Let's see here. The amplitude is going to be 1. The period is going to be 2 pi divided by 2, so pi. And the phase shift is going to be, let's see, c is -1, so the phase shift must be -1, that is 1. And the vertical shift is 1 here. And for the last one, we need to remember that it's not only the sine function these rules apply to, it's also for the cosine functions. So first off, we need to rewrite it as one before, and we get, let's see now, 2 cosine of 3 times x plus 1. And now we can once again just use rules and determine the different factors. So let's see now. We get that the amplitude is going to be 2, the period is going to be 2 pi divided by 3, the phase shift is going to be -1, as the c value is 1, and the vertical shift is going to be 0. So that was everything I had for this time, and I really hope you learned something new. Thanks for watching.